So we are going to dive into database design tonight. However, before we dive into that, we're going to do some setup. We're going to install two different applications, one called Beekeeper and the other one called Postgres. We're going to get our database set up. We're going to start writing our first SQL queries kind of outside our playground. And we're going to start actually having a database that we can execute commands on. Before we do all of that, though, how are we feeling about SQL so far?
Getting there.
Feeling like we're getting the basic queries down. We feel like maybe we're tasting a little bit about what a complicated query could be. We're starting to understand the importance of inserting data and being able to save it and being able to store user information.
hmm
Any light bulb moments throughout the week so far?
I mean, I had a few today working on the sequel, and just now Alba helped me with something, and I was like, oh, I really have to pay attention to spelling
Mm-hmm.
and syntax because was fine, but for an S. So yeah.
That will definitely get you. How are we feeling about the homework? Anyone start SQL Bolt? We like it. We hate it. How are we feeling?
It's almost the same as the challenges we were just doing.
Mhm.
Um is actually a little bit more helpful because
Okay.
it has the solutions button. If you get stuck or too stuck where you can't figure it out, you
Hmm.
look at the solution and then go back and actually work it out
Yep.
and do the steps that way. That way you're not stuck for hours on the same thing and you can't process it or you can't understand it. So
Yep.
even if you get a little bit stuck, you have the option of getting a little bit of help
Yep.
and figuring it out and then going back and we're like, oh, okay, so it's structured this way.
Nice. Yep. Good. Glad that that's helpful. Hopefully it is not it's not a one-for-one overlap, right? Not everything that you've learned in Khan Academy is covered in SQL Bolt, and there will be some techniques that you use in SQL in Khan Academy that aren't tested in SQL Bolt, but hopefully it's a good overlap because you can never fully master a programming language or concepts or stuff like that. There's always one more thing to learn. So hopefully the homework is good practice for you guys to kind of build that up. So what we're going to dive into tonight is different from what we've done all week. We're actually going to install two different applications. If you guys want, the links are all the links are all in the week 17 day 4 outline. I'm going to go ahead and drop that in the Zoom chat and the live stream right now. Now, if my Slack was open. Of course, you can just go about Googling these, and that's what I'm going to do to get these installed. So two applications I would like you to install. One is called Postgres.app. Postgres.app is the easiest way to get a Postgres database server running on your Mac. So if you do a search, if you head over to Google and do a search for Postgres dot app. Oh, one too many S's in there. Postgres only has one S. The first link you're going to get is the easiest way to get started with Postgres. You're going to see it's a little elephant here. Traditionally, every SQL variant has a different animal associated with it or a different type. Postgres happens to have this blue elephant that it uses. So in case you see different elephants or different animals around, it tends to be database themed. I have no idea what the history behind that is, other than elephants are known to have long memories and databases are known for storing data. So I'm guessing that's where it comes from, but I don't have any background on it to know for sure. So what we're going to do is we're going to go up to downloads up at the top. And then there is this downloads Postgres 15 universal. That's the one that we want to grab. So go ahead and hit the download button on there. That's going to install a DMG, which is short for disk image. We're going to go ahead and pop that disk image open. That's going to give us this drag and drop. Do not double click on this Postgres. Just grab it and drag it into your applications folder. You should hear like that bing sound once it's in. I already have mine in there, so I'm not going to hit replace, but you should be able to drag that in there. If your downloads take a minute, that's totally fine. Give everyone a second to catch up. Once you get your Postgres in your applications folder, we can kind of pause and wait for it there. Reminder that the week 18 homework is also now available. That week 18 homework will make a lot more sense by the end of tonight's class. We will be doing an entity relationship diagram. So you've got 2 weeks of homework now available to you. Week 17 homework, which is finishing up SQL Bolt, and then that week 18 homework won't be due until next Sunday, a week from this upcoming Sunday. And that will be your entity relationship diagram for your capstone. That is a really good homework assignment because you'll be getting personal feedback from me on the database design of your capstone. So that you can take all of the feedback from your entity relationship diagram and bring that right on into the following week, which will be integrating the database and getting our API set up in first steps from there. Does anyone need help with this Postgres step? Okie doke. If I am going a little too fast for you, there are in the week 17 day 4 outlines, there are steps that we're going through to installing all of this. So if I lose you at any point, there is written documentation here for how to get all of this set up. We are going to move on to our next application, which is going to be called Beekeeper Studio. So databases are always interacted with some kind of database client. That database client is usually going to be in our API server, in our node code. However, just like we can interact with APIs using Postman, we can also interact with the database using a tool kind of meant for developers to be able to execute those queries. So we are going to do a search on Google for Beekeeper Studio. The first link should be to Beekeeper Studio. And when you hit the download button for Mac OS, you can go ahead and grab this Apple Silicon download. It should say ARM64 after it. All of your Macs are based off of Apple Silicon, which means they are no longer Intel based. If you are using an older Mac for whatever reason, if you're tuning in from class somewhere other than the laptop that we give you guys, you can go to Apple up in the top and go down to About This Mac, and you'll see that the chip is listed here. If it has Intel in the name, that means you're going to want to grab that Intel download here. But for the vast majority of you, it will say either Apple M1 or Apple M2. That means that it's the Apple Silicon chip that you want. That's based off of the ARM64 processor architecture. So go ahead and hit the download button on the Apple Silicon. Unless you're on an Intel machine for whatever reason, you can grab that one. Just like Postgres App, you're going to go ahead and pop open that DMG that opens up, grab your Beekeeper Studio Ultimate, and drag it on into the applications folder. You will hear that it does a ding sound, showing that it's copied into the applications, and we should be all set to go on those. Everyone a minute, and then we will get these fired on up. Anyone need help? Anyone still downloading? Okay. So we are going to go ahead to our applications folder. I'm going to go to Finder. I'm going to go to applications over here on the left. Yours may look a little different or may not be in the list view. That's okay. Before we get into Beekeeper, we want to jump down to that Postgres app that we installed. So if you hit the letter P on your keyboard, it should jump you down to the P section of your applications. We're going to go ahead and double click on Postgres. And of course, I'm already out of date. You guys probably have the latest update. If you do not have the latest update, go ahead and hit install update. It will only take a minute to install. If you guys are already up to date, that's fine. Just give me a second to catch up to you. And this is where our screens may differ a little bit because I already have Postgres installed. Do you guys have a start or an initialize button?
Initialize.
Okay, go ahead and hit initialize. That's going to do the first steps to get our database set up, get the data directory. Now, after it's initialized, do you have a start button? What?
Not yet.
Postgres or template one.
It
What's
can't be
that?
clicked, but it's there.
I
It's
got
there,
it.
but it can't be clicked.
The different
Someone-
databases, it says Media Postgres or template one.
And work time.
And does it say running underneath Postgres 14?
I
Albert,
have,
go ahead. Albert, go ahead and share your screen.
is it 14 or 15 for Postgres?
14 or 15 is totally fine. Okay, so if your screen looks like this, if you have running going on, that's great. What you want to know is whatever is showing up right here is usually the username for your computer. That's the information that we're going to need for this next step. So does anyone not have this running showing up? Is that a no, Jennifer?
Oh, I'm sorry. No, I have it.
Good. Does anyone else not have this running showing right here? Okay, beautiful. This is going way smoother than it usually does. So we're doing pretty good. What we are going to do is move on to Beekeeper next. So I have a couple different databases in mind. But the main thing I'm looking at here is my username is hack upstate, right? So that's what I'm going to need to go ahead and connect in to Beekeeper. So I am going to go ahead back to my Finder and to my applications, and I'm going to pop open Beekeeper here. I'm just going to say, this is downloaded from the internet. Are you sure? Yep, we can go ahead and hit open on that. And down here, it says your free trial expires in 2 weeks. That is okay. We are not buying Beekeeper. Beekeeper has a community edition or a free license, essentially, where it disables some of the features, but none of the features that we really need. So you can go ahead and hit the X button down here. We do not need to pay for Beekeeper. Do not use any of your stipend money on that. Okay, so now we're in here, and Beekeeper connects to all different kinds of SQL databases. The kind of database that we want to connect to is called Postgres. So under this select connection type, we're going to go down to the third option, which is Postgres, and go ahead and click on that. Now, you may notice there are a couple different things in here. There is the host and the port, there is localhost, and as you guys know, we've been running React on localhost 3000. You know that the VS Code port, you may have noticed, is 5500. Postgres, for whatever reason, their default port is 5432. That's okay. We don't have anything else running on 5432, so we're all set there. What we are going to do is go down to this default database, and we're going to type in whatever username was showing up in the Postgres app. So for me, it's hack upstate. There will probably be two other databases in there, template one and maybe system. I forget what the other one is, but you want to take whatever one looks closest to your username. go ahead down into the default database, and then you are going to type in that username. We also are going to use that for the username right above it. So I'm going to enter hack upstate both in the user field and in the default database field. And then I'm going to click on the test button down here. Once I get it both in user and default database, I'm going to hit test. And if you get connection looks good, you are good to go. I'm going to come down here and I'm going to save my connection name as local DB. I'm going to go ahead and hit save on that. And you'll see over on the left here, you should have your local DB show up for the first time. If it does, we can go ahead and double click on that. And that should bring us to something that looks like this. Artrell, go ahead.
I need help.
Share your screen.
All right, so I had to wrestle with getting this. I thought I was looking at your screen for the longest time, then I realized it was mine. So I got lost of what to do after this.
Go ahead and hit select a connection type. The drop down kind of right in the center. And you're going to change that to Postgres. From there, you're going to enter your username that showed up in the Postgres.app.
Right there?
Yep. And then you're also going to enter that same exact thing into your own default database.
Default. Okay, here we go. All right.
And then you can go ahead and hit that test button, and you should get a pop-up that says connection looks good in the bottom right, which you did. So from there, we can call that connection name in the bottom text field. We can call that local DB.
All lowercase?
Doesn't matter. It's up to you.
Local DB?
Yep. And then that annoying your free trial expires is in the way. So hit the close button on that. And then hit save. From there, you can double click on your local DB that now shows up in the top left under the saved connection. Yep. And now you are good to go. You are all caught up. If you are on this screen and you see all that information schema over on the left, it means you have successfully connected into the database.
Schema?
Scroll up. You see where it says information schema in the top left there?
Got it.
That's basically the folder that's making the database all work under the hood.
Okay. Thank you, Max.
No problem. Does anyone else need help? Okay. So we have successfully connected to our database. Let's have some fun. What do you think the first thing we are going to do is in our database based off of everything that we learned?
Create a table.
Create a table. Are you cheating and reading my notes?
No.
So in order to do that, SQL to me is one of those things that really scares me, right? I kind of want to reference something while I'm writing it. So I'm going to go do a search for W3 Schools SQL because I can never remember that syntax, right? Is it a parenthesis? Is it the data type and then the column name, or the column name and then the data type? So we're going to go into the SQL tutorial here and go into the menu, and there should be something in here about creating a table. So I'm going to just scroll down until I get down to create a table, and then I'm going to see this syntax. That's great. That's the syntax that I want to reference as I'm creating my table. So I'm going to create my table called teachers. So I'm referencing the syntax here. It says create table, table name. So create table. Then I'm going to call my table teachers. Then I'm going to put in my parentheses, and I'm going to think about, okay, what traditionally goes into my table? So I'm going to say, hey, my teachers have a name, and we're going to use the data type of varchar. Varchar is just like a string in JavaScript. It's just saying, hey, I can put in a string of characters. Now, you may be saying, why 255? By default, the length of a string in Postgres is 255 characters. If you need more than that, you actually use a different data type called text. So we start with our first column. Then we come in here and we go, okay, what other information do we want to store about our teacher? Maybe we want to store their email address. So that's going to be another varchar with 255 characters. Up to 255 characters. Does not need to be exactly that.
What is that again? Variable chart?
Variable characters, as in it is a variable length. It could be up to 255 characters.
Thanks.
Varchar is like an older version of a string. Every SQL database has their own kind of variances of data types. And then the last one we're going to do is, let's say, num of students. Actually, I'm going to do it with underscores. And that is going to be a data type of integer. So I'm going to put my semicolon down at the end. And now you guys were saying, what does it mean to run a query, right? Because when we were in Khan Academy, everything would just like show up over on the right-hand side. But when we're working in real production databases, we need to tell it, hey, it's time to run this. Go take whatever I typed in and tell the database it is time to execute or run that SQL query. So we're going to go down to the bottom and go ahead and hit the run button on that. And you should see, Alba, go ahead.
Do we need to add IDs?
Not at this point. We will work our way up to those. But great question. Yes, normally when we create tables, we would create something with an ID, but we're gonna work our way up to that. Okay, so down at the bottom, we should see no results, 0 rows affected. Well, that's okay because we didn't really make any new rows, right? What we really want to get back is that there are no errors. So if we look over here, we can see our teachers table got created. Okay, that's pretty cool. If we double click on it, we can now see that there's no data inside of our teachers table, but it has our name, our email, and our num of students.
Cool.
Okay. So I'm going to go back to the first tab up here. This is my query tab. This is where I can kind of write my commands. So now I want to get some data inside of that. So I'm going to go back to W3 Schools. I'm going to look at their menu and I'm going to switch over to their SQL insert into. So I'm going to go ahead and click on that. And I'm just getting a little refresher here, right? Insert into table name. I specify the names of the columns. Then I put the keyword values. Then I go ahead and input those values. So I'm going to go ahead and insert myself as a teacher. I'm going to insert into the teachers table. And I need to specify the columns that I am going to put my values into. So I'm going to say name, email, and num of students. And I'm going to put in the values of Max and my email and the number of students. I don't know, 5. So what is going to happen here is as soon as I hit run, Beekeeper is smart enough to only run the command that I have my cursor on. So don't do this, but I'm going to show you what happens. If I come up here and I click into my create table, you see how this gets a little bit more bold. Beekeeper is recognizing that because my cursor is up here, that's the command it's going to run. So if I hit the run button down here, I'm going to get there was a problem. The teachers table already exists. Remember, this goes back to yesterday's class. There is no undo in SQL. If I decide that I want to add in another column here, I can't just rerun the create table command. I'm going to either have to use the alter table command, or I'm going to have to drop my table, delete my existing table, and then recreate it, which I may have some data loss over. So anyway, just showing you here, wherever your cursor is, that is the command that is going to run by default. We can run multiple commands at once, but we're going to work our way up to that. So I'm going to come down here. I'm going to click back anywhere into my insert into, and that's going to make my command kind of go a little bit more bold. That is showing me that is the SQL command that's going to run. So I'm going to come down here and I'm going to hit the run button. And it's still going to give me issues because I am totally wrong. It is still trying to run both commands. So what we need to do is go ahead and highlight out this insert into. And you notice what will happen down here? This changes to run selection. Now it's going to ignore whatever is in my create table up here. So when I click on that run selection button, I get column max does not exist. Is that what you guys got?
Mhm.
Okay. That is because I can never remember if it is single quotes, double quotes, or backticks that we use. And it is always the last one that we try. So I'm going to try to do single quotes instead of double quotes. And I'm going to highlight that command again and hit run selection. And now you should get a 1 rows affected. You'll still get a no results, but that's okay. Artrell.
So if we use varchar, should that be the single quote where if we do text, it's the double? Because in Khan Academy, they had us do the double quotation.
It's a little different based off of what SQL variant you're using. So
Light
SQL
versus bold.
Exactly. Yeah. So SQLite calls it a string and not a varchar, right? They're accomplishing the same thing, but they're a little different. In the Postgres syntax, whenever we're inserting a value, we use single quotes.
Okay.
For a varchar. If it's a number, you notice we don't need any quotes in there. But when we're inserting a string or a varchar value, that's when we want to use those single quotes.
Okay.
So
Thank you.
hypothetically, good question. When we go back over to our teachers table, which we can just switch over to that tab up here, it says no data. Well, there isn't any data in there from the first time that command ran. But what we're able to do is refresh this data. So I'm going to come down to the bottom and I'm going to go ahead and click on that refresh button. And that will actually show me, hey, my name, email, and num of students actually got inserted from my SQL query. Now, I'm going to test something really quickly. For some reason, I am in read-only mode, and that is not where I intended to be. So give me 1 second to figure out why I am in read-only.
That's the same for me.
Yeah. I am wondering.
Does it have something to do with the fact that there's no ID? Because if you hover over it, it says like there's no ID. And I know that some kind of like software systems, like they require like a unique identifier for each row.
That is a good guess. So let's see. I've got two hypotheses. One is yours, Brian, and the other is that we installed the Pro edition. They call it Ultimate, and instead we should have maybe installed the open source version that is free. So let's see if we can fix. Let's see if we can test your first theory, though. How would we go about, what command would we use in order to add an ID column to our teachers table now that it already exists?
Update.
Update is for updating the data of the row itself. But we don't need to update the row itself. We want to do what?
Alter.
Insert.
Alter table. So in order to reference that, I'm going to go back and I'm going to use my Command F and find my alter table in W3 schools. And here it's going to tell me, okay, I can alter table. I need to put the table name, the keyword add, and then whatever column name and data type that we want to add. So I'm going to go ahead and delete out everything in here. I've already run those queries. I don't really need it. So I'm going to delete that out and I'm going to try my alter table. I'm going to alter my teachers table. And then I am going to say add. And I'm going to add a column called ID. And then we get a little funky because Postgres uses a slightly different column for IDs than SQLite did, which is what Khan Academy ran off of. So instead, we're going to use the data type serial primary key. I'm going to come down here and I'm going to hit the run button. And now I got no results, 0 rows affected. Okay, pretty cool. I'm going to go back over to my teachers table and I'm going to go ahead and hit the refresh button here. And now I've got my ID showing up here. That's pretty cool because if I go back to my query, and I'm going to clear this out. Actually, I'm going to comment that out for now. And I do another insert into my teachers table. And now I'm still only going to specify the name, the email, and the num of students. I'm going to purposely leave out my ID. Even though we have that added as a column, when I go ahead and insert something else, and put my semicolon in there, I can go ahead and hit that run button. Remember, I have this commented out, just like in VS Code. If you hit Command/, it will put in the commenting out features. So I have this commented out, so I can go ahead and hit the run button. But if I did have multiple scripts in there, multiple SQL commands, I could just go ahead and highlight it, and that will turn my run into my run selection. So I can hit that. I'm going to go back to my teachers tab. And again, I'm the only one in here. But if I come down and I hit this refresh button, you will see that not only did Latonia get inserted, but because we use that serial data type, it automatically generated the ID for us. And that's actually pretty common to let databases generate the IDs because the database knows what the last ID was and can sequentially update that ID in there. So what I'm going to do, anyone need help? Did anyone get their 2 rows? Cool. So I'm going to go ahead and close out of this table. And I'm going to go ahead and close my query. I'm all set with it. I don't need it. And I'm going to go ahead and reopen my teachers table. And Brian's hypothesis was completely correct. Now notice our read only is now gone in the bottom right. That is a perfect example of, hey, IDs are important in databases because Beekeeper itself couldn't update the data without knowing what our ID column was. So you notice we not only said serial when we altered our table, we also put in those keywords primary key. Look at what's showing up at our key, our ID right now. That's a symbol for a little key to show us, hey, the database is keeping track of all of these rows using this column. What that allows us to do, there's 2 things we could do. We could go back in and we could write another query. So I opened another query by clicking on the little new tab icon up at the top, and we could use that update command. We could update our teachers, and we could set the num of students equal to 10, where our ID is equal to 1. Whoa, where did I get all of that from? I'm going into my teacher's table. I want to set number of students. This number 5, I want to set to a 10. So I'm going to include that where my ID number is 1. I could say where the name is equal to Max, and that would achieve the exact same thing. So I'm going to go back over to my query. I'm going to hit the run button on that, and I should get no results, 1 row affected. If that's the case, I can go back over to my teachers, hit the refresh button at the bottom, and see that I have my 10 in there now. Okay, so we're feeling pretty good. We're seeing our SQL running. Little differences, right, in Postgres, but that's okay.
Query again?
Yep. Artrell, go ahead.
I'm sorry, Max. I was handwriting some notes, so I didn't get a chance to put in what you did with the alter table. I got as far as the alter table teachers, and that's as far as I got.
Sure. Let me see. I did. Well, let me back out to it. Let me share. I believe I did alter table teachers, add let me reference, it was ID serial primary key.
All right, give me one moment. I'm sorry, guys.
No, don't be sorry.
Yeah, it's all good. While you're doing that, Archel, Max, is it important for us at all to save these queries like after we run them? For example, that update that we just ran. I mean, it updated the table, but
That
should
update
we
is
save it or?
nope.
Okay.
SQL commands aren't like our code. Once they're run, they're run. They're saved into the database. If we reboot our computer, that is still going to be saved in. So it's not the end of the world if we lose our SQL queries, because unlike our code, once it's run, it's in there, it's saved into the database. And that's really why there is no undo, is because once that query runs, it's done, it's finished.
Okay. Yeah, that's what I was thinking. I just wasn't, this gives like a default to like to save, and if you got to close it without saving it, it asks. I just didn't know if that was something important for this app. But okay.
Great
Thank you.
question. Yeah.
Oh, email. No. Uh-oh. Oops.
So I'm going to show you guys one more kind of cool thing about Beekeeper. Just like we use Postman to test our API calls, and Postman makes it a little bit easier to understand, like, hey, are we missing something in our URL, or can we add something into the body, or how is our authorization really working? Well, Beekeeper is also very helpful for not only running our SQL commands and being able to visually see those tables, but also if I go back to my teachers table, because we've got our ID in here, I can actually modify the data directly. So yes, we just did an update query and we were able to change it to 10. But the cool thing is Beekeeper can actually run that update query and even write it out for us. So if I double click into my num students, you'll see I get a text field. I'm going to go ahead and change that to some other value. And when I click outside of it, you'll see down here, I now have reset and apply. I'm going to move that up just in case the bottom of my screen is blocking it. I can actually go ahead and write and modify several things, but it's not going to actually update that. It's not actually going to run that SQL query until I hit the apply button. So I'm going to go ahead and hit apply down here. And now you'll see that turns green for a second, and is done. So I can go ahead and hit that refresh button down here, and you will see my number of students was updated without me having to write a SQL query.
I'm still on read only.
Do you hit the refresh button? Do you have your ID with a key at the top?
I would
I-
close out of that one and try like opening up another teacher's from the side menu.
Yeah, so hit the close of the tab up here. And then just double click on teachers again and see if you still have read only at the bottom. You do? That fixed it, or you have read only?
I fixed it.
Okay, good.
So question, does this lag? It doesn't update in real time, I guess you can say?
You do have to hit the refresh button. Yes, when you modify some data, it will not automatically live update here, and that will be true anywhere we use the database.
Okay,
So even when we start doing our APIs and we insert a new row and then we go back over to our front end, that data won't automatically show up. We'll have to manually refresh it.
gotcha.
Marcella, do you still have a question or you need help?
Can I share my screen with you, please?
Yes, you can. And Jennifer, I'll come to you next.
Or someone else is sharing? All right, all right. Never mind, never mind.
Oh, okay.
All right,
It's like, I definitely hit the stop share.
all
okay.
right. So,
So you've got your ID added, but we missed somehow setting it as a primary key. So what we're going to do is go back to your, your query one. How'd you manage
The
that?
same thing that happened to mine. I had to get out of the teacher screen and go into another and open the teacher again.
Okay, so go ahead and click into teachers, and then you have a little X button. Hit that, and then go over the icon for a database is these kind of 3 circles on top of each other. If you've noticed in the YouTube thumbnail, there may be some like weird random thing. That's the symbol for a database. And then double click on teachers. And now Beekeeper has woken up and has realized, hey, my ID is a primary key. So because it's found the primary key, it now no longer has read only down here. That means if you double click in one of these fields here, you can type in whatever number you would like. And now when you click outside of that, you now have an apply button down here. So you can go ahead and hit apply, and that will turn your orange value green and let you know that that is now updated in the database.
okay. All right. So I'm up to speed now, Max.
You're all caught up. This is just our own little playground, right? We're not really accomplishing anything here, but you're seeing, hey, we can execute these database commands. We can get them to show up. We will be using Beekeeper later on when we start developing our app. We're going to be using Beekeeper to set up a blog database. We're going to be, building apps. We're going to learn how to make our own APIs starting next week. And then we'll be using the Postgres NPM package in order to be able to write our SQL commands, have them show up in Beekeeper, but then also use our API to pass that information back to our React app to have that show up.
So maybe this is not
I'm
the right
trying to
time
be
ask.
fair here. Raise your hand because you got 2 people.
Oh
in
yeah,
front.
sorry.
Schneider, go ahead.
Oh, damn, I forgot my question. What the heck? I think I was gonna ask. Oh yeah, the README thing. We gotta have IDs so we don't, or is it gonna default to README unless we put the ID?
It will default to read only, and it really is best practice to put an ID on pretty much any table that you create. There are some edge cases for that, but yes, it's usually a good idea when you make a table to automatically include not only the ID column, but set it to the serial primary key, and that way Postgres will automatically generate those IDs for you. Jennifer, go ahead.
Real quick, I gotta say shout out Elva, because Elva did call out the ID column like
She
when we
most
first started
certainly
making
did.
them.
And you know what? I didn't know how quickly I could get to the syntax for serial primary key because every database is a little different. And I couldn't remember off the top of my head the serial primary key. You guys will see down the line why I don't have that memorized in like 2 weeks from now when I show you a tool called an ORM, an object relational mapper, which is basically going to allow us to write all of our SQL queries using JavaScript without having to execute SQL manually. But we're going to work our way up to that because an ORM, while it is a widely used tool, it is a tool. And so we make sure we spend some time on using raw SQL and then kind of show you how to upgrade it. Similar to React. We don't want to teach you React right out of the gate because it's important to understand what JavaScript is, what's built into the browser, get our HTML, get our legs under us, learn the JavaScript syntax, and then kind of layer the tools on top of it. The same goes for SQL. It's important to be able to kind of see Beekeeper, to see how those queries are running, to know what the data types are, because you may be hired into a situation where they say, hey, we've got this database. We don't actually want you to build an app. We want you to execute queries and be a data analyst. Well, as a data analyst, you would be writing raw SQL, right? That is kind of how you would be interacting with the database. And so we're going to learn how to build an API using raw SQL, of how we can write some SQL into our JavaScript and have it execute in the database. And then we'll layer in this tool called the object relational mapper, which will allow us to run our SQL queries by writing just JavaScript. So that's what's coming down the pipeline for you guys. Jennifer, go ahead.
Yeah, thanks. Your query and my query are different, and I don't have an update.
Okay. Do you have at least 2 rows in your teachers table?
I do.
You have an ID in your teachers table. And does the key show up?
Yeah.
Then you're good. That's all that really matters.
Okay, thank you.
No problem. Xona, did I answer? No. Oh yeah, there you are. Did I answer your question, or do you still have?
No, but I'll ask it later on because it's more complicated. I'll ask it later on.
Okay. One second. Jordan, do you need any help? See if I can just get you over whatever you're stuck on.
Yeah, mine says that port 5432 is already taken.
Who's taking 5432? Go ahead, share your screen. Let's take a quick look. Chances are, if you're stuck there, someone else may get stuck there eventually.
No, it was just when downloading the program, I couldn't get it to download correctly.
Okay.
Like when I do this, oh, actually, hold on, I already did that.
So down in the bottom right.
So server settings, when I go to do this and then initialize.
Yeah.
Okay, so let me take a quick look. I'm going to request remote control.
Patrick, are you getting that also?
By any chance, when you opened your Postgres app, did you just double click on it from here?
I did. I dragged
That's
it
your
over
problem.
and then, okay.
We cannot open it from here because this is a disk image. So it's kind of like a virtual CD. Yes, Apple goes all the way back to those days. When you install a new application, a disk image, a .dmg, kind of pretends to be a CD. So imagine if you were like running an application off a CD, it would have no place to save the data because the CD is read only. I know that is a super old
Like
school way of
100
thinking.
Yeah, it's
but
like a
that's
100-year-old.
yes. So what we're going to actually do is I'm going to quit out of Postgres from here, and I'm going to eject it so we don't run into any issues. And for anyone else, because we've got them installed, if we go into Finder, we can actually hit the little eject icon because we're done with the install. From here, we're not going to open it from down here because this is still coming from the disk image. So I'm actually going to quit this one out and I'm going to go fresh into applications. And this goes for anything you install with the DMG. It is very tempting to double click on it. Don't double click on it from that disk image. Go over to your applications folder. Now, when you pop open Postgres and hit initialize, something is really holding on to that port. All right, fine. You want to Tango? We'll Tango.
In the meantime, Jordan, I need you to stop fronting because I know you definitely burned some CDs in your lifetime. So don't try
Yeah,
to call out
good
Max for the
100
CD
years ago.
reference.
Brings me back to like the pre-iPod days where they had the like whatever the Sony ones were with the
MP3 players.
MP3 players, but they still had a
Yeah.
disc in them. So it was
Yep.
like a hard mini floppy disk. I forget
Yeah.
what they called them.
The Walkmans, maybe?
It was the Walkmans, but it was like the digital Walkmans that had, it wasn't a cassette, but it was like a hard floppy and.
I know what you mean. It was
Oh,
like a hybrid between like a SD and like a floppy. It was a weird
Yeah.
time for MP3 players.
I miss
It
LimeWire.
sure was. Oh, I can
I don't know
tell
if there's reason-
LimeWire. I go back to the Kazaa days.
Yeah, right.
I mean,
Because
not that
that's the goat.
not that I ever downloaded anything illegally or anything. That's totally. All right, your Postgres is really holding on because it is cranky.
I think he downloaded it twice, Max. I don't know if that makes a difference or not.
Yeah, but it's not running anymore, which is why I'm confused as to why it won't give up that port. I'm going to advise that you reboot your computer and then try and open Postgres from the applications folder and see if this initialize button works.
I was about to say, turn it off and turn it on.
Yeah, unfortunately, I don't know why it's not giving up that port, but I think a reboot should fix it. Is anyone else having any problems? We want to get them fixed today so that next week we don't run into any issues with our Postgres. Okay. So you guys may be wondering, hey, we've run these SQL queries. We're feeling pretty good, right? We got our create table. We understand the selects and the inserts and the updates and the deletes, and we know how to drop a table. And next week, we'll get into not only how to create a new table, but how to create a whole new database inside our Postgres server. And we're going to learn next week how to connect into that using our JavaScript code. So all of that's really cool, but you may have noticed we've used things like name and ID. We've done our cross-referencing, and we get into this interesting spot of, okay, but how do we know how to design our database? Most databases don't have 1 or 2 tables. They have 20, 30, 100 different tables. And there may be different ways of structuring that database design. So what we are going to get into is database design. And then after we get through these slides, I've got 2 videos for you on entity relationship diagrams. And then towards the end of class, we will go back to our old friend diagrams.net, which you may or may not have used for your blog app diagram. Oh my God, it hates me. And you can't even see my screen to see me struggling. Okay, here we go. Jordan, I will help you during the break to figure out what's going on there. I can't imagine what else you would have installed that would be hanging on to port 5432. So we'll figure that out during the break. So we're going to go into database design. I sourced a lot of this from Microsoft. If you are curious, this article, if you're a reader and not a visual person, if you're not a slide person, this article is going to go ahead and cover everything that we're going over here. This is the best intro to database design that I have found that isn't like an entire course. This is, it's a little bit of a lengthy article, but I source all my information from here and put them into slides just to make it a little bit more digestible. If you're a reader, go ahead and check this out over the weekend. It may be helpful. And the only other thing that I want to say before we dive into the slides here is that database design is an entire semester's worth of course at college. So when I was in high school, I actually took 2 different courses. I took one in SQL, which was an entire semester long, and we learned how to write different join queries and how to get pretty complicated, and worked our way up to actually 100 lines of SQL query all in one go. So obviously we are rushing our way through SQL here just to get the basics down. The same goes for database design. I'm trying to crunch basically an entire semester's worth of database design down into one class. The reason why I do that is because it's best to just practice, right? It's best to get into your capstone. It's best to just create a couple different tables. So this is kind of crunching down the core tenets of database design into one night. Now, there may be some concepts that you don't really grasp tonight, but as you're working on it, you may have certain terms click. You may start to realize, hey, we could benefit from a different database design if we, while we're working on our capstones, find that there are different tables that we're creating. So anyway, I just wanted to throw that out there. This is one of those nights where like everyone will put Roadrunner on their instant, their 30-second feedback form. But feel free to ask questions as we're going, because a lot of this is conceptual. This isn't our typical, I'm hitting the run button and it's not working, or where am I missing my semicolon? This is all of the theory behind database design. And honestly, it's not something that I really understood until I started designing databases poorly. And I would run into issues where a user would contact me and say, hey, I updated my last name here, and now I'm somewhere else in the app, and my last name is wrong. And I'd be like, oh, I violated one of the core principles of database design. So you guys will see that kind of as we go through the slides tonight. But just wanted to throw that out there as heads up. You can make a full career out of database SQL and database design. There's a lot to learn in here, so I'm trying to just narrow it down into what you need to get going. Okay, so some of this should just be a review, right? We have tables, and tables have rows, and we have columns. So think about that as a spreadsheet. There may be a few columns, but there can be an unlimited number of rows. Columns are usually limited out. I think you can't have more than 255 of them in a table. Having 20 columns or more is considered a very large table. Traditionally, our tables will have something between 2 and 10 columns. That's not a hard and fast rule. If you need more columns, you can definitely add them. But when we think about how our database grows, it should be growing in number of rows, not in number of columns, right? Because with any table, you could say, oh, well, I'm going to put all of the data across the rows, and then the columns will be on the side. Yeah, you could get away with that in a spreadsheet, but even spreadsheet applications are better set up to say, what are your pieces of information? What are the different fields? That's going to go across in the columns, and then anything that we add will be our rows. And that's kind of, it isn't truly unlimited, but it is, we can have thousands or hundreds of thousands of rows, but we're limited in the number of columns we can have. You just heard me call a column a field. Just like in our object, we have key value pairs. Well, that makes up kind of a field of data, right? So if you hear me say field, it just means it's a column, and fields have specific data types, as we've already seen in our SQL. So we've already seen our ints and our varchars, and we're going to get into text, and we just introduced the serial data type. And then every row represents a single item. So the table called products, every row would be its own individual product. So good database design has our information divided up into different subject tables. So if we've got a customer and that customer maybe has address information, that customer may have some products that they've purchased, that customer may have some products that they've saved. We want to reduce that redundant data. So what we try and do is we split out that data into separate tables so it's easier to have it be relational. Now, one thing to call out there is that we've been learning about this relational database, right? And we've learned that all SQL databases are relational databases. Can anyone guess what the opposite of a relational database is?
Unrelated?
A non-relational database. And no, I am not making that up. There are two kinds of all databases, relational and non-relational. Now, for a long time, up until like the late mid 2000s, the SQL was the dominant database type, and no one really used any other type. But as computers got more and more powerful, and as we kind of figured out where they were growing and how storage worked, and when storage started to become very cheap, we ran into this new kind of database called a non-relational database. Does anyone happen to know a non-relational database? It's
Blob,
okay. What's that?
blob.
I'm not familiar with that one, but I do happen to know that there are blob data types in non-relational databases, so it very well could be its own database. The most common non-relational database by far is called MongoDB. And Mongo kind of works all off of JSON, which is very interesting because as we've learned from the Weather API and the New York Times, our JSON objects can have other JSON inside of it. We can have arrays inside of our JSON. We can have objects nested in other objects. And that's what Mongo supports. So the principles are still the same of a non-relational database in terms of create, read, update, delete. We have our different ways of making those transactions in the database, those queries. However, relational database is very different than non-relational. In non-relational database design, we actually have one mega big object. So we have a customer, and that customer may have an array of previously purchased products, and we may actually be duplicating the data in that database. Non-relational databases are a little bit harder to design because they don't have strict rules. In SQL design, we're going to get into the 3 key rules. But in non-relational databases, just throwing that out there, it's a completely different way of thinking about it. While Mongo is by far the most dominant non-relational database, you may run into databases like Firebase or Apache CouchDB. There are a couple other ones out there. Just throwing that out there so you guys know that the database design does not go one for one. We design non-relational databases entirely different. Good database design has IDs, and it has not only what we call a primary key, but also a foreign key. That foreign key is basically a primary key in another table. We tell the database about those keys, and we design our databases so those keys cross-reference, so it becomes easier for us down the line to join that information together, whether it's an inner join or a left join or whatever it is. Because we structure our database in the design properly, it makes it easier for us to update or maintain that data down the road. Good database design is all about the accuracy and integrity of your information. When we do good database design, we don't want what we call 2 or more sources of truth. We want one source of truth. When I want the customer zip code, I can go to one table and get their zip code. I don't need to go to 2 or 3 other tables that may have zip code in them and then have conflicting information. And finally, it is good for data processing and reporting. At the end of the day, a database is just the storage of information. We need an efficient way to be able to extract out the information that we're looking for. And so good databases make it easy for us to generate reports and say, okay, how many orders did we get? How long did it take us to process that order? All different pieces of information that we could store in our database. When we have our design done right, it makes it easier for not only the business needs, but also for us as developers to be able to update and extract the information out of the raw data that gets saved into the database. Any questions on any of that? Sorry, this is your boring slideshow where, you know, you just buckle in and go through it. So kind of as we have the software development lifecycle, the SDLC, where we talk about planning and writing the code and the quality assurance of it all and that kind of stuff. Designing a database tends to fall into the traditional steps. So we figure out, hey, why do we need a database? Do we even need a database in the first place? Are we designing some kind of website where we can just throw the information into our HTML pages and call it a day? Lots of websites are like that. We do not need a database all the time. Once we do decide we need a long-term storage, once we decide, hey, this should survive, if I turn off my computer and turn it back on, I should be able to access it. Or, hey, we have multiple users kind of saving in information here. We need to store and centralize all of that. The next step is to find and organize it, right? This should sound very, very similar to the steps of the software development lifecycle. Once we've got all of that information, once we kind of organize all of that out, we divide that information into tables. We figure out, hey, how does this information get referenced without breaking any of the rules of database design that we're about to get into? Once we've got that information into the tables, we identify the columns that are inside those tables. That's like identifying the keys on our JSON object, right? We got to identify what the structure of that table is going to be. Then we identify our primary keys. Sometimes primary keys already exist, right? If you were designing a course database and there was a Writing 101 course, that primary key may already exist. If there isn't, it's easy enough for us to assign our own primary key. Then we identify and set up table relationships. Hey, I've got a table called teachers and a table called students, and every student has a teacher ID associated with them. That means that every one teacher has many students. Because of that, we can use the foreign key of teacher ID on the primary key of the teachers table. And because of that, we're able to cross-reference that, do a join and say, hey, if I want to get all of Max's students, I can use teacher ID to do a join and get all of that information. Once you do all of that design, then you go back and you refine it, right? You show it to someone else. You say, hey, do you see anything wrong here? You may have some relationship set up where you say, well, there are multiple students and multiple teachers, and because the students have multiple teachers, we need to define that relationship a little bit differently. We need to insert what we call a bridge table. We'll get to that in a second. And then we make sure the 3 normalization rules are in place. And those are kind of like laws of physics for the database. They are rules that we never want to break. And so once we've got everything designed out, which we use our entity relationship diagrams for, we make sure that we apply those normalization rules. So we'll get into in 1 second. Any questions on that? I don't really agree with this slide, but Microsoft says it's important, so I guess it's important. This is all about what's the purpose of the database. Make sure you have that defined in a paragraph. Make sure you know who the users are. Oftentimes, we will design a database for developers and release that database out into production. And it turns out that users had a different plan for that database. I will say that the identify who's going to use it is very important, because I have developed features for my boss before, and I thought that he was going to create 5 or 10 of something using this feature. And then I get a message and he's saying, hey, this isn't working. And I'm like, okay. And I go in and I load the page and he's created 500 of what I thought he was going to create 5 of. And I go, oh, database was not designed for that, right? I was not planning on you creating so many of those things. So identifying the purpose is helpful in terms of knowing who's going to use it. Is this going to be used by a lot of novice users? Am I going to have power users in this database saving information? All kind of worth considering when you're designing your database for the first time. You may decide that a different kind of database is a better fit for you, like a non-relational database, depending on the kinds of data. I am a sucker for SQL databases, but anyway, just throwing that out there. So oftentimes you say, where do I start with all of this process? Basically go to the business and diagram out how data flows around a business. Imagine that you're an appliance repair shop. How do you go about storing that information in the database? How do you say, hey, where does the data get generated? Well, we have a customer that walks in with their appliance and says, I want to get this fixed. Okay, well, you may not have a database in place for that business, but there's already data flowing, right? Okay, let's go look at our form. Let's go look at the piece of paper that the person at the front desk fills out. What kinds of information are they collecting? Well, they're going to get the name and the address and the phone number of the customer, but that's not the only information they're going to get. They're going to get the make and model and serial number of the appliance. They're going to generate some kind of time estimate of when it's going to be ready. They may generate an estimate of what parts are required to fix it. That is all very helpful before you get into actually designing your database, right? We also have something called a DFD, which is similar to an ERD. The ERD is your entity relationship diagram. That's showing you how some tables are related to other tables in your database. For a DFD, a data flow diagram, that's kind of how does the business work? Okay, the customer walks in and interacts with the person at the front desk. Then what happens? Okay, well, the person at the front desk puts it in a folder for a repair technician. Okay, now that the repair technician is working on it, what happens? They give it to the parts department. The parts department gives it back to the repair technician. The repair technician updates this information and hands it back to the front desk person, who calls the customer and says it's available for pickup. Sometimes thinking through down to that level is helpful. So think about your capstones, right? A lot of you guys have created your interfaces, you've created your pages, but now think about, okay, well, what happens when I want to add that new food bank? I need some form to fill out so that gets saved into my database. Okay, what happens when we post a game and realize we need to cancel the game? Okay, well, there needs to be some interface for that, right? There needs to be who can cancel that game. We don't want anyone to be able to cancel a game. Maybe we want the person who created the game plus an admin on the site be able to cancel it. Hey, there's a tornado coming. We don't think anyone should be playing basketball right now. I want to go in and be able to cancel all of them. So thinking through not only how that data gets inputted, but then what is the output? Does the output come out on a website? Because designing a website compared to designing some printed piece of paper is going to be very different. And believe it or not, all of that factors into organizing the info that we need to put into the database. And then break down that information as much as possible. We don't want to store name, right? We talked about this a little bit last night. We had something called name in the database, and then we had another table called first name and last name. That first name and last name is going to be very helpful, because if you want to email out to all of your database and you want to just say, hey, first name, if you don't have those fields broken down, it can become much harder to just use a part of a person's name. So breaking that field down is very important. Okay. I've already kind of covered this. We divide our information into tables. We start breaking out the pieces of the information. So we say customers, products, supplies, orders. We're able to classify the information down into that. If we place something like products and suppliers on the same table, think about what would happen there. Okay, we've got a GE supplier, and their address is 123 Main Street in Syracuse, New York. Now we have another product. Well, that product would have to duplicate all the information. Oh, this product is also coming from GE at 123 Main Street in Syracuse, New York. So at that point, it makes more sense to split that out and use that primary key and the foreign key to prevent that duplication of information. What happens if we store a supplier, but they don't have any products? Well, if they were in the same table, I couldn't put in the supplier's information without putting in some dummy information about a product they may not have yet. But they may start creating products down the line, and I still want to store that information. So that's a benefit of keeping it in different tables. Yeah, that's pretty much it. Turning information into columns, make sure you're breaking down that information. When you have their address, you shouldn't just have one column for address. You should have the address line 1, address line 2, city, state, zip, all as separate columns. This is a kind of an interesting one. You never store calculated data. So think about that for a second. Let's say we've got a customers table, and we want to be able to tell how many orders that customer has placed. You may say, hey, I'm going to have a new column called in my customers table called num orders. And every time they place an order, I'm going to add 1 to it. But I have all kinds of orders information that I need to store. So I'm going to have my own separate table called orders. I'm going to create a new row every time they place an order. And now I'm going about my day, and a customer calls me up and says, hey, I want to cancel that order. Sure, no problem. I go to the orders table, I delete out that row, but now I forgot something. I need to also go in the customers table and subtract 1 from the number of orders. That's not good database design. What's better database design is to say, hey, I'm going to write a query where I say wherever the customer ID equals whatever, wherever the customer's name equals whatever, go count the total number of orders they have. Believe it or not, that is much more efficient to get that information than it would be to store it and update it over time every time you add or subtract an order. And then what we've already talked about, hey, get it down into the smallest logical parts, break out that address, break out their name, whatever it is. More columns for that piece of information is usually better. It's much easier to concatenate information together than it is to break information apart. Okay, primary keys. We saw and made our first primary key technically in Khan Academy. We also did that tonight. Every table should have a primary key. We use either the keyword auto increment, or in Postgres, we use the keyword SQL. It is possible to use other columns as primary keys, like we said, writing 101, although it's pretty rare for that to happen. It's usually pretty traditional that we have an ID that we allow the database to generate. Sometimes it may be data that already exists. And then the main rule here that's important is primary keys can never be duplicated. So you can have a ID in a student's table that matches the ID in the teacher's table, that's fine. But in the student's table, you cannot have 2 students with the ID of number 5 or whatever number it is. Primary keys always have to be unique, and the database will enforce that. So if you are running some SQL queries, you run some insert command, you forget that you run that and you try and run it again, the database will error out at you and say, we cannot insert a student with that ID because that ID already exists. Table relations are what we've learned about joins. We have a primary key and a foreign key. We're going to learn in our entity relationship diagrams how to tie those 2 together so that we're planning through the database design. You can have you normally only have one primary key in a table. You can have multiples. However, it is very common to have multiple foreign keys in one table. What makes a foreign key is it's just a column that's referencing a primary key in another table. So it's foreign because it's not the key for that table. It's foreign because it's referencing a primary key in another table.
Hey, Max,
Yes,
can a primary key be made of two different parts?
it can. You can make what is called a compound or a joint primary key. So you only usually do that in a bridge table to basically say, hey, teacher 1 has student 1 and teacher 2 has student 1 as well. In a bridge table, you would use two primary keys or a joint primary key. However, it's usually common to say, hey, every table, we're just going to make a column called ID, and that's going to be the primary key and the only primary key for this table. Okay. Splash some water on your face. The spurt's important. Got you for another 3 minutes. We have different table relations. So we have one-to-many relationships. Think about this student. And the way I like to think about database design is thinking about it as an actual spreadsheet, right? Where every tab on the spreadsheet is a different table. So we may say that one teacher can have multiple students. So we don't want to store all that information in one table because we would be duplicating the teacher's name in multiple places. So instead, we make two different tables. The first one is our teachers table, which keeps track of information like first name and last name. Our students table, which keeps track of not only first name and last name, but we have these two IDs. What we are saying in a one-to-many relationship is the ID right here can be reused as a foreign key in the teacher's table. In other words, if we did a join on the teacher's table and the student's table, we could overlap the ID of the teacher with the ID in the teacher ID students table to figure out that, hey, Max Matthews has two students, Nate and Edna. Primary key, foreign key. One teacher to many students. It's called a one-to-many relationship. We also have many-to-many relationships. However, this is very commonly avoided in database design. So let's think about our products and our orders. A single order can have many products. One product may be included in many orders. That means we have a many-to-many relationship. It's what we call an anti-pattern, right? What we do is we create what we call a bridge table to save that information. So we have our orders and we have our products, but what we do is we bridge the gap between these two tables by creating something like order details. Now we say, hey, order ID 10,248 has a couple products included in it. It has product ID 11, which is up here, and 42 and 72. That means that when we start a new order ID down here, that's still storing the customer information and all of that stuff. We can tell what products are in the order because they're stored down here in this order's details. So what we say is that orders has there can be many orders, there can be many order details for one order, and there can be many products in order details for the one product up here. So we basically say this becomes a one-to-many and a many-to-one relationship instead of a many-to-many relationship. Important thing to remember there, many-to-many, whenever we are trying to store multiple of both types, is that we use that bridge table between it. Okay, 7 o'clock. The good news is I only have 5 more slides to go, and then we will dive into entity relationship design, and that will prep you guys for your homework tonight. And then we will create our first entity relationship diagram based off of some requirements that we have in the outline. Take your break. Be back at 7:25. Jordan, if you can stick around, please do. 7:25 break. See you guys. Is our one-to-one relationships, right? Our one-to-one relationships are less common because usually all of that information is just stored in one table. However, sometimes it makes sense to break that information out. If you want to have a customers table and you want to have a separate address table, you could say that one customer can only ever have one other address. Like I said, not very common, but those are our 3 kinds of relations in our database. One-to-one, one-to-many, and then many-to-many. And we try to not have many-to-many by solving it with a bridge table that does our one-to-many and then our many-to-one. I know that's all kind of in a vacuum. You're going to see how we design that in our entity relationship diagrams next. Refining the design. Oftentimes your database design is not what you will start out with. You will have to go in and do your revisions, right? I think you guys are learning that with your wireframes right now. You're getting some stuff to show up on the screen, and then you're realizing, hey, I need links to get in between those pages, or I'm going to need a form to be able to update the data. Oftentimes it makes sense to start with dummy data. Don't start with real production data, but try and load up the database, insert your information, kind of see if it works. You can always modify your table structure and columns to make your data more efficient. Quick things to check for here. Did you forget any columns? Do you have any columns that are calculated or could be calculated? Do you have duplicate information in 2 different tables? Do you have a lot of columns with very few rows? If so, can that table be better architected? Is info broken down into the smallest parts? Does each column relate to whatever the name of the table is? And then are all the relationships represented? Do you actually have your primary keys and foreign keys and all of that stuff?
So, sorry, that's more of like a rough draft. So it's a rough draft of what you want to create, pretty much. Okay. Cool.
Exactly. Yeah, you're not going to get your database design right out of the gate, and you're going to be designing a bunch of stuff and then go to the table and realize you've got the same information in 2 different tables. And then you're like, oh, okay, I've got to make sure I update that and pull it and do my joins right and all of that stuff. Does anyone see a problem with this table?
That
It's
one empty slot.
all the
There's an empty slot there. Yeah, I've got my product ID and my product ID 2. What happens if I want to place a 3rd product onto my order? I only have 2 columns. Okay, well, I guess I can fix that by adding a bunch of new columns, but I don't want to limit my orders to the number of columns I have product IDs for. So what we end up doing is we do our bridge table. This is our one-to-many data, and this is kind of one of the hardest things to wrap your head around in database design. If you do not know how many items are going to be part of the order, what you end up doing is making this bridge table. So the bridge table has its own ID that we don't really care about. What we care about here is that we're bridging the order information together. So we're saying order ID 1 is relating to the orders table over here, but then order 1 has 2 products with it. Product number 5, which is my shampoo, and product number 2, which is my soap. Now, order ID number 2 only has 1 item with it. It only has item 15. Then we've got our order ID 3, which is still referencing our table over here, but now we've got product ID 20 and 8 on it, which would reference more information in the products table. So basically, whenever we have a many-to-many, whenever we can have many orders that have many products on them, we bridge it to say, hey, there is one order that has many order items, and that many order items is going to relate to one product down here. Artrell, go ahead.
All right, I'm looking at this table. So the one that says order items
Mm-hmm.
and the column that says order ID,
Mm-hmm.
where there are the 2 3s. The first 3 has ID 4. I see that from the left table that says orders.
Mm-hmm.
The second 3 has 5. Is it because it's more than one item for order ID 3?
This is the ID of the order item, not of the order itself or of the product.
I guess where I'm having an issue is, so order ID, the second number 3 has an ID of 5, where the one above it has an order of 4.
Right. So this isn't representing the ID of the order or the ID of the product. It is representing the ID of the order item.
Okay, so it's numerical for that specific table.
Correct. IDs are almost always specific to whatever table it is, unless it's a foreign key, at which point our order ID here is referencing the ID over here. So this order ID is a foreign key, and this product ID is a foreign key because it's referencing the ID here.
Okay,
This ID is referencing order items. This ID is referencing orders, and this ID is referencing our products.
okay.
So whenever we say ID, we normally mean the ID of that table. However, when we are writing our query, we don't really care what the ID is here. We just make an ID because databases like having a primary key on every row. But when we write our join query, we're going to join order ID where the ID matches orders.id, and we're going to join our product ID where our products.id matches our product ID from the orders item.
Okay, so I guess where I was confused, I thought we were doing that already with the ID 4 and 5 with order ID, the 2 3s, but that's not taking place just yet. That ID is just, so for the order items table, that list, the column of IDs is just listing for that specific table. It's not bridging anything yet.
Correct.
And if I can add something, like Artrell, like a good way to think about it would be like when you have like a service like invoice, you know, that you hand to a customer or something, like all those items on there, like each of the line items that comprises the total, like just imagine that those things all had like an ID in the system. Like you're looking at it on a paper, so as a human, we don't need to see that as an ID. But just imagine that for the database, like every line that is on that service invoice has an ID, because that's just how the database likes to classify stuff, you know.
That's a really good example, and let's just model that out really quickly. And we're actually going to use that example for our first entity relationship diagram. So let's say we've got our customers, and our customers are going to have a ID, and they're going to have a first name and a last name. Right? So I have 1, 2, 3, John Smith, Sally Fields, and Max Matthews.
But you put your last name in there with the first name, Max.
Oh, I'm breaking database design, breaking all kinds of rules tonight. All right, there we go. So I'm gonna throw in some shading here. Okay, now we've got our products, and our products have a name and a price associated with them. So we've got laptops, we've got desktops, and we've got tablets. And my laptop is $10, my desktop is $20, my tablets are $30. Now we need to build an invoice for that product, for that customer. Now, one customer can have multiple invoices. They may come back and buy more laptops from me, especially if they're only $10. But that invoice could also have multiple products on it. They could end up buying 4 laptops, and next time they come back, they could buy a laptop and a desktop. Give me 1 second, Jennifer, and then I'll call on you. So what I'm going to do is I'm going to come down here and I'm going to create my invoices table. Now my invoices are going to have an ID because every time that customer buys from me, they get a specific ID. We are also going to include the customer ID and the product ID, and maybe even the quantity of that product that they bought. So if I've got a customer who bought, let's say Sally bought a laptop and she bought 2 of them. But at the same time, Sally may have bought a, oh, this gets a little messy because we don't share the invoice ID, but let's just say Sally also bought tablets and she only bought 1 of them. Now we can do a join and we can say, hey, go get wherever the customer ID is 2. So we now know we're talking about Sally over here. Now go get the product ID information 1 and 3. That must mean we're talking about laptops and tablets. So what we're doing is this table is joining the information, invoices, between the customer's ID and the invoice's product ID. So we're kind of using the customers table and the products table and using invoices as the bridge between the 2 tables. Jennifer, go ahead.
I was curious if we could use C1 for customer number ID 1 or P2 for product ID 2.
You can. And
Yeah.
I've seen it both ways. I have seen some database designers say, we're going to call it ID because ID is the purest thing, and there's going to be an ID in every single table.
Mhm.
I have also seen people say, there is no hard requirement to call the ID, the primary key column, actually call it ID. So I've seen some people always make the ID whatever the name of the table is, which makes it easier to do something like that. And then it's easier to say, oh, invoices.customer ID must line up with customers.customer ID.
Mhm.
Now,
Okay.
proper database design would actually split this out 1 step further. Because the problem is we can't store multiple products on 1 invoice right now. We can't use 1 and 1 because if invoice ID is our primary key here, we now have 2 primary keys. So to actually design this out properly, what we would do is we would say our invoices has a invoice num. It has an invoice ID. It has a customer ID, and it has a product not a product. It has a just an invoice ID and a customer ID. So we would say, hey, invoice 1 belongs to customer 2, and then we delete customer out here. We move these over, and then we've got a kind of a double bridge going on here. So what we're able to say is, hey, the invoices table, the customer ID here references the customer ID over here. The invoice ID here references the invoice ID here. And the product ID here references the product ID up here. That would actually be proper database design. But that gets a little complicated. You can almost think of this as the invoice items table.
Mhm.
And then this becomes the invoice you could do another column in there for the invoice item ID. Anyway, good example. Does that help?
Oh, yes, definitely does.
Okay, let me see. I think I finally made it through my slides. Oh, okay. Most complicated slide for last, of course. So remember I was saying about the laws of physics? This is the laws of database design, and that is called normalization. And think back to the invoice example, because what we broke one of the normalization forms here, which is why we had to create that fourth table. The first normal form says every row and column intersection exists a single value, never a list of values. Why? Well, how are we doing that? I can't go back to my database and say, hey, my invoice items has product ID 1, 5, and 7 on them. We are never allowed to store a list of values in one single cell, one row and column intersection. So in order to solve this, we end up doing a bridge table to get that one-to-many relationship going on. We are not allowed to store list values in our database. That's kind of the easiest one to understand. The next one says each non-key column is fully dependent on the entire primary key. So if we are looking at order ID, product ID, and product name, the product name must be removed because it is only dependent on the product ID, not the order ID. In other words, we can't store two pieces of information about the product on the same row. We should put product ID and product name off in their own table and then have another table for our product ID and order ID. The reasoning behind that is because if I go update the product name, now the product name in the products table is not going to be up to date in the orders table, which has both the product ID and the product name. In other words, it's a relational database. Make the data relational. Don't store all the order information in the orders table. Make a products table and relate the products table to the orders table. Brian, go ahead. Oh, you're still on mute.
So just to kind of try to tie the concepts together, in that original example that we used from the slides, which was the orders and the order item that our trail to get clarification on, would that order items, would that be considered the bridge table in this set?
Yes.
Okay. All right. Just wanted to make sure.
So this is basically saying we're not allowed to put product name up here because the product name is also related to the product ID. And so the rule says, hey, make that its own table, make relational data relationally designed in your database. Good on that one? Now, when I go over your homework for next week, you've got an entire week to work on your ERDs, and we're going to go into how to design an ERD in a second. But you're going to get feedback from me and go, well, why is that wrong? And I'm going to say, this breaks the second normal form. You're going to go, stupid laws of database design and normalization, and have to come back here and reference that. But when you do your database design, you will break a couple of these normalization rules, and I'll give you guys not only say, hey, you can't do this, but I'll show you an alternative of your ERD of how to normalize the data. And then, so the third normal form is saying not only every non-key column must be dependent on the original entire primary key, which is what the second normal form is, but non-key columns should be independent of each other. Okay, what's that mean? If you store product ID, name, final price, and discount, you wouldn't be able to just update the discount without also updating the final price. In other words, if we have a order table and it's got a final price and a discount, what the database is saying is that we should be able to update the discount and not have to update any other key in that row and still have the data make sense. In other words, don't store calculated values. That is a very long way of saying two items cannot be dependent on each other. Well, when would an item be dependent on the other one in the same row? Whenever a calculation takes place. So basically that third normal form, don't store anything calculated. Calculate it whenever you need to run the query, whenever you need the data. Your data should be raw data. It should never be anything calculated. Okay, I saved this.
So would a solution to that be like if you gave all the discounts a discount table and there was discount IDs, and then that could then be like if the calculation had to change, then you could just summon that, like pull that discount ID.
The general idea is that you shouldn't be like if we go back to our invoice example here, and we have the price in this table and the quantity in this table. In our SQL query, we could say, take the quantity and times it by the price in the product. And because we're interjoining those tables together, we could do that math. So we would break the rule here if we said total price. That would break the rule if we did that calculation of the third normal value. Because if I said, oh no, just kidding, they only bought one of them, now total price would also be wrong. So we would just write our SQL query instead of inserting that into invoice items. We wouldn't have this column at all. We would write our query to calculate the total by taking the price and multiplying it by quantity, even though those are in two separate tables.
So I get what you're saying there, but I guess I'm still a little confused. It's like, and maybe I'm just stuck on that specific example, but how would you handle discounts then? Would the discount be calculated like after the total is calculated and then like on the application side it would do it?
So you could do discount here and say there's a 10% discount and a 20% discount. And now
I see.
You would do your quantity times your discount times your price.
Okay, that makes sense. I guess, yeah, because I was just wondering, because I didn't know if maybe the discount was there. I guess in your example, maybe your example was to show that the discount wasn't needed in the table, but I guess since it was there, I was just trying to figure out where it would fit.
Discount does not break the rule. Final price is what breaks the rule because of discount. Right? So final price is a calculated thing here. And so we're calculating it based off of the discount. And that's why it's not allowed.
Okay, I see. Got it.
All right, are we all super bored? We're all sick of me talking and want to watch a video? We're going to learn about entity relationship diagrams. Kind of like you didn't hear the import or export features. Those are not part of diagrams.net. I will just plant the seed that if you design your entity relationship diagrams very easily, it becomes much easier to write your own SQL to create your tables with the right data types. Because again, you're planning it all out before you're actually executing it, right? Lucidchart, and if you play enough with diagrams.net, there is a plugin that will actually let you generate all of your SQL based off of what you have designed in your entity relationship diagram. However, there's definitely something to be said about getting the practice of writing out that SQL yourself and referencing that. Any questions from that video? We're going to spend a couple minutes designing it out and using diagrams.net. I do have one more video for you, and then we will play around with making our ERD. And I realized I forgot to pause the recording, so I'm going to have to do some editing. You guys hate it when I push you right to the end, but I'm going to show you how to get started on your homework, right? So I'm going to actually use this database that we've been playing around with, right? This is just a spreadsheet right now, but we're going to get started making the entity relationship diagram for all of this. ERDs are industry standard. If you work at Apple and make an entity relationship diagram and then go work at Google and hand them the same entity relationship diagram, Apple will sue you for intellectual property theft. I mean, they will also be able to read the entity relationship diagram because that is the same standard used everywhere, right? It's actually a big debate going on right now, and a case I think that made it all the way to the Supreme Court over whether non-compete agreements are legal. So basically, if you work at Apple, they can write something into your contract that says you're not allowed to work in this similar industry for 2 years after you leave. And so there's a big debate going on right now of whether or not that's a legal thing to put into contracts. Kind of interesting, completely unrelated. I'm going to head to my diagrams.net, and I'm going to leave this open over here. I'm going to hit the start button. It normally fires up a diagram you already have open. You can just go ahead and hit create new. And then in here, instead of just picking the blank diagram, you'll notice one of the top options is your entity relationship diagram. ERDs are one of the most common diagrams because it's so helpful to have a visual layout of the database. So I'm going to go ahead and create that. I'm just going to call it orders ERD. And they've already got me started with some things in here, but I don't want to start with their stuff. So I'm going to just go ahead and highlight everything on the screen and go ahead and delete it out. You're welcome to follow along with me if you want, or you can just kind of go along for the ride and practice this. I will say the week 18 homework does not need to be in diagrams.net. So if you find it's easier to use paper and pencil or a whiteboard or you know, Figma or whatever you want, it is totally fine to use a different application for this. Artrell, go ahead.
All right, so I'm following along and it says use root folder. Do I say yes or pick a folder or?
Root folder is fine, yeah.
Okay.
That's just saying where do you want to save it. And they have a bunch of different save options. So if you go file, save as, they'll let you save it wherever you want on your computer.
Okay.
Okay, so from here, instead of just pulling out shapes from over here, I'm going to collapse this general panel and go down to the entity relationship. And down in here, there are all kinds of tables that are helpful. I'm going to go ahead and grab this first one because we're not going to model out the data types, but I'll show you how to add that if you wanted to. So I'm just going to drag this out over here, and I've created my first entity. Remember, an entity is like a table. Jennifer, go ahead.
Here we go. Which diagram type did you use?
The entity relationship diagram. It should be one of the top 5 or 6.
Max, if they pick the blank one, do they still have access to the entity relation?
I don't think so.
Okay.
Let me see. So I'm going to do device. I'm going to say create new. This is the one that you should pick. But if you hypothetically didn't pick that and did the blank diagram, entity relation is still over here as one of the options to pick from. So yes, you can do it from the blank diagram as well if you want. And then when I'm in here, I just clicked and dragged to highlight everything and then hit the delete button, and that kind of cleared out whatever was in there. Okay, so we're going to get started with our customers table. And my piece of advice is start at the table that has the most amount of related data, right? So if you have a bunch of data that's stored in different tables, start with whatever your users table is or your customers table. I found that to be helpful because sometimes you're like, wait, I've got a primary key here, but it goes to a foreign key somewhere else. And then you go, that foreign key has got a link to a primary key in here, and you get lost in where you're at. So I say start with your users table or your customers table if you have one of them. So I'm going to name my table customers. And I'm going to say, hey, my customers are going to have a primary key of customers ID. So this PK is going to stay over there. What other information do I have? I have their first name and their last name. So I'm going to go ahead and type in first name, and I'm going to type in last name. Now I'm kind of stuck because I don't have a row 3. Or what if I had multiple rows? Well, if you go into a range over here, down at the bottom, there are all of these buttons for the table. If I click on the entity, the whole table itself, and then go to the arrange tab, down here, there are all of these different things that we can remove rows and delete rows and all of that. So if I have the table selected and I click on the last one, it will automatically delete the last row out. Now, let's say I've got more information about the customer that I forgot about. You can always go to this one here and it says insert row after. And if you click on it a couple times, it's going to extend out your entity relationship diagram to add in additional rows. Artrell, what did we lose you? This is why cameras are required to be on, because I can see the panic in your face.
All right, so I created my little table, and I'm looking to the right. So where in yours you have style, text, and arrange, I just see text on the right hand side. So that's
go
where
ahead
I'm like,
and click on the entity kind of up where it says customers, and then you should get all 3 tabs up here.
I do not.
Okay, did you grab the table from the entity relationship section instead of the general section?
I did.
That will do it. So you got to go to the entity relationship and then go ahead and grab this first one and drag it out.
No, that's what I did. I did do that.
Oh, okay. Share your screen.
You got it. So yeah, I just have text here, and I have this so far.
Interesting.
Go for it.
Do I somehow have a different version of diagrams.net? I guess you just didn't have the right section of the table selected. So sometimes if you're in, like if you have text selected, it will only show you the text here. But if you click on the table at the top and just single click on it, that's what will get you the arrange over here where you can delete out the row.
Okay.
So it's very picky about, like, if you have something selected here, you notice your arrange is gone. It's
Right.
all very context specific. So if you click on the table once, that will get you into your arrange over here.
Okay.
Anyone else need help?
Can't we
Jennifer, go
just
for it.
click on the row we don't want and click delete? Like, I just did that without changing anything.
Yeah, that works too. What you can't do is add a row from there.
I would have to.
You should be able to click and drag one in though, just like you can drag in a table, you can drag in a row. Does that make sense?
Always forget, yeah, this is how you do that. Instead of using this arrange tool over here, if you come over here and hover over the 4th item, it actually says table row 2, and that's got the foreign key and unique ID as part of it. If you drag that over and see how that whole box turned purple, when I let go on it, it's going to go ahead and drop that in for me. So if it's easier to delete by just clicking on the row and hitting the delete button, you can do that. And then you can come over here to the table row and go ahead and drag that in. And that's what's going to add in a new row to customers. So whatever's easier for you. Just because we only have a couple minutes left, I'm going to try and do this quickly. What I like to do is get all of my tables made first, and then I draw the lines between them all. So I'm going to do my product ID, I'm going to do my name, and I'm going to do my price. I'm going to do my invoice items. And my product ID. And my quantity. And not spell anything right, because why would I be able to do that this late at night? And then I've got my invoices. Now this is a very small ERD, and that's okay. But what I do have going on here is I've got this bridge table, right? I've got my invoices, and my invoices reference a customer ID. So in this left one, I'm going to say my customer ID is actually an FK. It's a foreign key. Then I click on here and you see these like little faint arrows. If you hover over it, it's going to turn to a darker blue. You can grab that and drag that up to my customer ID. Then you can use the style tag to adjust what the front and ending line shapes are. Where is my cardinality though? Excuse me, diagrams.net. Where did my cardinality go?
It's in your style. You see, yep. I was just gonna say,
But this isn't.
well, it's under that. If you go back, you see where it says none? Underneath the line.
Oh, thank you. Thank
Yeah.
you. Clearly, Latonia has been making ERDs more recently than I have been in diagrams.net. So there are two different drop downs here. One is for the start of the line and one is for the end of the line. And I can never remember which one is which. So it's usually easier to just click on one and hit an arrow and then click off it. And you can see, hey, that one added right on this side. And so we reference our cardinality. We say, okay, what is our one to many? We can have one invoice and multiple customers. But for the sake of your homework, you don't need to worry about the cardinality. I like to just draw the lines just so I have everything referenced and have everything labeled as a foreign key. So if you were handing this over to a database engineer, they would cry blood because you didn't have the cardinality on it and they wouldn't know what the relationships were. But for the sake of our homework, you can just draw the lines out and say, hey, this is a foreign key here and it relates to the primary key over here. So we have our product ID here. We label that as a foreign key because it relates to the primary key over here. So we click on product ID, we make sure we get the arrow coming outside of that, and we draw it up to the product ID here. And now I've got some crisscross applesauce and it's getting hard to tell, right? So the cool thing about diagrams.net is that we can kind of drag them around and position them in a way that makes a little bit more sense. Alba, go ahead.
So we're supposed to be doing these for our
Capstones.
capstones, correct?
Yes.
So if you don't have a product and the only thing that you could actually make this for would be to create an account, sign up for an account, or to update their base information, I just need to make those 3 diagrams and make a primary key, second key, and then connect those where the customer would log into the sign up and then.
So think about though, what if there are multiple user accounts that are allowed to modify one food pantry? So now we have to do a bridge table and we have to say, hey, user ID 1 is allowed to edit food pantry 4. And there may be maybe one user ID who can update multiple pantries worth of information. So then we start designing that in and saying, all right, we need a bridge table because many users could edit many pantries worth of information. So we're going to have a users table, we're going to have a pantries table, and then we're going to have maybe a permissions table or an edit table or something like that would use both of them as a foreign key. And then you can also start thinking about your pantries are probably going to have at least 10, if not 20 different columns, right? Their Facebook URL, their Twitter URL, their hours on Monday, their hours on Tuesday. kind of thinking through all of that is what you'll want to design into your ERD.
Okay, all right, thank you.
Does anyone else have no idea where to start for their capstone and needs a little push for their ERD? Or if you want to think about that, give this class time to sink in and then follow up with me on a one-on-one. That's also totally fine. But this is not due again until not this upcoming Sunday, the following Sunday. You guys have plenty of time to think about this. And if you're sitting here and going, oh my God, I hate diagrams.net, I can't believe he brought that back up into class. You are welcome to do it on Post-it notes or on a notebook or whiteboard or whatever, and just take a picture and send it in. We're not constraining you into using this tool. This just happens to be a very good tool for diagramming. Who knew? It's called diagrams.net.
And Max, they can schedule one-to-one time for help with this too, right?
Absolutely.
And I also posted the feedback form, so if you all can please take 30 seconds to do that, that'd be great.
Office hours will likely be 5 p.m. on Sunday. That is subject to change Sunday morning. I will let you know if that does change. And I do believe there are still some slots open on my calendar for this weekend. So you are welcome to book. And there are also slots available tomorrow as well. So if you guys have anything to book, definitely take advantage of that. And other TAs are available as well. That spreadsheet has all of the different TA links.
Max, do you have mine for tomorrow?
Yes, 4 p.m.
And did you see my cancellation?
I didn't. I saw your message. Did you cancel it in Calendly?
No, I don't know how to do that.
Oh, okay. I'll cancel that for you. So there's a 10 a.m. that just opened up as well. I saw your message and just thought that you canceled it in Calendly, so I didn't bother to confirm, but it's opened up now for someone else. Thank you for canceling in advance.
Sure. You're welcome.
All right, that's all I got for you guys for tonight. You have made it through Intro to Databases. Starting on Monday, we can officially call ourselves full stack developers. We are going to start making our own APIs and tying all 3 pieces of the stack together. Our front end in React to our back end, which will be building in Node and Express, will be reintroduced to Node and introduced to Express tomorrow. I'm sorry, on Monday. And on throughout next week, we'll be learning how to integrate our SQL into our JavaScript and pulling in the database and using Beekeeper to see kind of how those commands are executing. So very exciting stuff. All comes together now. Have an awesome evening. I will see you guys hopefully Sunday at 5 p.m. or at one-on-ones or on Monday.
Hey, Max, just real quick, Kalai has her hand up, so I
Yep.
don't know if she wants to jump in.
I have
Thank
a
you.
quick question about
Shoot.
2 things. So for capstone, do you think 55 minutes or 25 minutes, which one will be okay, work out? Because it's just
Totally up to you. You can do, I personally would like to book like a 25-minute one
Okay.
and then have 2 days and then book another 25-minute one. Just so it's kind of all condensed in one session. But if you feel like you've got a really long list of questions, go for the 55. You know, there's a reason why I have them both open on my calendar. It's really up to you of how long you think it will take. And just go from there.
next question is, so I have my databases in Excel. So
Mhm.
is that possible for me to like import them into SQL and make it analysis and stuff? Is it? Okay, so
Absolutely. Yeah, if you just do a Google search of like CSV to SQL, you'll find 50 different tools that allow you to export it as a comma separated values file, and then convert that into insert statements in your SQL. So it is very common to have regular spreadsheets and import them in. Yes.
sure. Thank you.
Max, sorry, I just booked like 2 other ones this weekend.
Okay.
Okay, so I just wanted to let you know. Don't hit me. You might get sick of me by the end of the weekend.
All good. I won't get sick of you. I'm glad you only did 25 minutes, but if we end up going short on Sunday, it would be better to lean for 25-minute sessions, but we'll see if you can take them all up. And if you can, that's totally fine.
Okay, cool. Sounds good.
Thank you.
I'll stick around for a couple minutes just in case any questions pop up. Otherwise, have an awesome evening.
Bye, guys.
Good night.
Archel.
Yeah, Max. So on the diagram,
Mhm.
I'm having an issue with like trying to add arrows and delete arrows. If you can just show me how to do that real quick. All right, I'm gonna share my screen.
Go for it.
All right. So I was trying to find. I messed up.
Oh boy.
Somewhere.
Okay. So I'm going to
Yes.
we're gonna click into this arrow and we're just gonna hit the delete button. And that's gonna clear
so
that out.
click and then the delete. Okay.
And then we're gonna delete over here. Whoa, delete. Go away. I told you to delete. Oh, now you're. Oh, I can't pinch to zoom apparently on remote control. Okay, if I can just grab the arrow itself and then hit delete. Okay, let me try. Sometimes if you zoom in and then it looks like I have that, doesn't it?
It did.
Okay, how about if I do this? If I say, I've had enough of you, delete that column. Nope. Delete this column. There we go. All right. So now I'm going to zoom out. And what we want to do is don't think about it as arrows between entities. Think about it as lines between fields. So what we're going to do is we're trying to get customer ID here linked to the customer ID up here.
Right.
So what we do is we hover over that line and you see the very, very faint arrow right over here.
Now I do.
It's also hiding over here. Once you get your mouse over it, it's easier to see it. So I'm going to say, I want this one, and I'm going to click and drag it all the way up to my customer ID. And then we can always, of course, adjust and move things out of the way. So to practice, our product ID lines up with our product ID up here. So if you hover over that, you're going to go over to the arrow, click and drag it until it turns blue for the row that you want to connect it to, and then you can drop it in. And then, of course, you can always say, oh, well, those two arrows are on top of each other, so you can move stuff around if you want. So I'm going to put that back, and I'm going to take out those arrows just so you can practice if you want to.
If I want to delete it, I just kind of click on it and then press the delete button to get rid of it.
You got it.
Okay. All right. Thank you, Max.
No problem. Any other questions for the evening? Jordan, I swear to God, if your database is broken again,